Welcome to the deep dive.
Yeah.
So, looks like we're diving into how Google keeps its systems running smoothly,
Smoothly.
even with the just massive scale at which they operate.
Yeah.
And you've given us some really excellent source material
Yeah.
excerpts from the Site Reliability Engineering book,
It's like the
which I've heard is
so-
the Bible, yeah, on how Google approaches reliability.
Absolutely. We're going to take you on a journey
Okay.
through its core principles.
Okay.
We'll get into the nitty-gritty
Yeah.
and share some real-world examples of how SRE works its magic at Google.
All right, so let's start with the basics.
Sure.
What exactly our Site Reliability Engineering?
So it's a bit more than just your typical sysadmins.
Okay.
SRE is about using software engineering principles to tackle the complex challenges of running systems at Google's massive scale.
So it's like using code and automation to make sure everything runs smoothly.
Exactly. And to understand why that's so important, you need to grasp the sheer scale they operate at.
Yeah.
Think thousands of machines failing,
Oh, wow.
hard drives breaking, all in a single cluster every year.
Wow.
SRE helps them manage all of that
Yeah.
and prevent those hiccups from impacting users.
That's a lot to juggle.
Yeah.
Are there certain key principles or areas that Google focuses on
Sure.
to maintain this reliability?
Absolutely.
Okay.
Availability, latency, performance, efficiency, change management, monitoring.
Wow.
It's a big job. But SRE breaks it down into manageable pieces, all with a focus on engineering solutions.
So instead of just reacting to problems,
Right.
they're proactively building systems to prevent them.
Precisely. And one way they do this is by building their own specialized tools and APIs to have greater control over their systems.
It sounds like they're building a fortress of reliability brick by brick.
Yeah,
Tell me more about how they approach building these super reliable systems.
sure.
What strategies do they use?
So simplicity is key. They aim to make things as straightforward as possible, automate wherever they can, and break systems down into smaller, more manageable modules.
Yeah.
It's like building with Legos. Each piece is simple on its own,
Okay.
but you can create incredibly complex and robust structures by combining them in smart ways.
I like that analogy.
Thanks.
And speaking of automation, I'm sure Google's all over that.
Huge, yeah.
What role does it play in their SRE strategy?
So automation is huge E for Google, and it goes beyond just saving time.
Okay.
It's about empowering everyone to execute tasks,
Yeah.
not just relying on specialized experts.
Okay.
So, for example, they have this system called Borg, which automatically manages where software runs on their servers.
Okay.
This means that if one server fails,
Yeah.
Borg can instantly move the software to another one without any human intervention.
That's amazing.
Yeah.
Sounds like Borg is the unsung hero of Google's reliability.
You could say that.
And what about monitoring? How do they keep tabs on everything that's going on?
So monitoring is absolutely crucial.
Yeah.
Google even has this concept of the 4 golden signals for monitoring:
Okay.
latency, traffic, errors, and saturation.
Okay.
Their philosophy is that if you can only monitor 4 things,
Okay.
these are the ones that matter most.
Only 4. That
It
seems
seems like a lot, but
surprisingly manageable. Yeah.
yeah.
But given Google's scale, the monitoring systems themselves must be incredibly complex, right?
You're right. Their monitoring system called Borgmon IS Complex,
Okay.
but they strive to keep the core principles of their monitoring as simple as possible, focusing on those 4 key signals.
Okay.
This helps them quickly identify and address potential problems before they impact users.
So it's about prioritizing the most important information
Yeah.
and not getting bogged down in all the
Yeah,
details.
exactly. Now, you can't talk about reliability without talking about software releases.
Okay.
Google has a very intricate process for pushing out software updates safely and reliably.
I bet they do. Given how many users they have, one little mistake could have a huge impact.
Oh, yeah.
So how do they manage that release process?
So they have a sophisticated system called Rapid,
Okay.
guided by something called blueprints, and of course an incredibly robust testing system.
Okay.
It's like a carefully choreographed dance where each step is planned and executed with precision to ensure a smooth and successful release.
So picture this. A giant automated pipeline where code flows seamlessly from the developers' desks to the live servers that power Google's services.
You're getting it.
That's essentially how it works, right?
You're not far off. They even use special labels like dev, canary, and production to track packages in the release pipeline. Think of it like air traffic control for software updates.
Okay, I'm starting to see the complexity here.
Yeah.
But with all this automation, what's the role of an actual SRE? Like, are they even needed?
Oh, absolutely. Even with all the automation in the world, things can still go wrong. And when they do, the SREs are the ones who spring into action. In fact, being on call is a core part of the SRE role at Google.
That makes sense.
Yeah.
Even with all those checks and balances, you need humans to oversee things and be ready to jump in when the unexpected happens.
Exactly. They've developed special protocols and tools to manage those incidents effectively and get things back on track as quickly as possible.
So when something does go wrong, do they have like a specific playbook that they follow?
They do. It's called an incident management protocol.
Okay.
And it helps engineers work through the problem systematically and get things back up and running.
Okay.
It emphasizes clear communication and planning, especially when you have multiple teams scrambling to find a solution.
Okay, so it's like a well-rehearsed fire drill. Everyone knows their role and what to do, even under pressure.
Exactly.
Do you have any like interesting stories from those incident responses?
Definitely.
Okay.
There's one where a search endpoint failed.
Okay.
And the engineer on call had to get creative. They ended up using a simple command line tool called curl to diagnose the issue.
Curl. That's like using a butter knife to fix a jet engine.
Well, it worked. It just goes to show that sometimes the simplest tools can be the most effective.
Yeah.
And you always need people who can think outside the box when things go wrong.
It's fascinating how even in this world of sophisticated automation, human ingenuity and problem solving are still essential.
Absolutely.
So we've talked about building these robust systems, releasing software, and responding to incidents.
Right.
What about testing? How do they ensure that these systems are truly reliable before they even reach users?
So testing at Google goes beyond just checking the code.
Okay.
They test configurations, use production probes to see how things behave in a real-world setting.
Hold on. Production probes. Are they testing things in the live environment with real users?
They are.
Wow.
They have what they call hermetic tests, which run in a controlled environment, but then they have non-hermetic tests, which interact with live systems.
Oh, wow.
It's a way to make sure things work as expected, even when faced with the unpredictable conditions of a live environment.
That's pretty hardcore.
Yeah.
I can see why they're so confident in their system's reliability.
Absolutely. And it's all about layers of checks and balances, right? And speaking of checks and balances, capacity planning plays a big role in all of this as well.
Okay, capacity planning.
Yeah.
I'm guessing this is all about making sure they have enough servers and bandwidth to handle the massive amount of traffic that Google gets.
It's more than just throwing hardware at the problem, though.
Yeah.
It's about understanding their service reliability goals and planning accordingly.
So they don't just buy a bunch of servers and cross their fingers?
Definitely not. They developed a tool called Oxon specifically for capacity planning.
Okay.
It helps them understand how much capacity they need to meet their reliability goals, even as their services grow and evolve.
It's amazing how much planning and preparation goes into keeping those systems running smoothly.
Yeah.
But what about the data itself? That must be the most important thing to protect, right?
You're absolutely right. Data integrity is paramount at Google. They have a multi-layered approach to make sure that data is protected against all sorts of failures.
Multi-layered, huh? What are some of the lawyers they use to protect their data?
So they use a technique called out-of-band data validation. Which essentially means they have systems that constantly check the integrity of the data independently. It's like having a separate team of auditors, making sure everything is accurate and in order.
This seems like a pretty thorough process.
It is, and it's paid off big time. There's a story about how Google Drive's automatic data validation and repair system prevented a potential data loss disaster.
Oh, wow.
It automatically detected inconsistencies in the data and fixed them before any users were even aware of the problem.
Okay, that's seriously impressive. It's like they have a safety net for their data.
You too.
But what about launching new services? That must be a pretty stressful process, even for Google.
Launching a new service is a big deal. And Google has a very elaborate checklist to ensure those launches are both successful and safe.
A checklist. Isn't that a bit basic for Google?
You might think so.
Yeah.
But checklists are actually a powerful tool for managing complex processes, especially when the stakes are high.
Yeah.
They help ensure that every step is considered. Every potential problem is anticipated. And nothing falls through the cracks.
So what kind of things are on this checklist?
Everything. What other systems does the service rely on? Do they need to inform partners about this launch? What if they miss their deadline? It's all carefully considered.
It sounds like they've planned for every possible scenario.
Yeah.
And I'm guessing they've had to adapt that checklist over time.
Oh, for sure.
Especially as they've ventured into new areas like mobile.
Absolutely. When they launched Android, they had to significantly adjust their process to account for the unique challenges of a mobile operating system.
That's a good point.
Yeah.
So they're not afraid to learn and adapt their processes as they go.
Absolutely not.
I'm sensing a theme here.
You got it. SRE at Google is all about continuous improvement and learning from experience.
Okay.
It's not just about following a set of rules. It's about understanding the principles and being able to apply them in new and challenging situations.
Okay, so they've built these incredible systems. They have these amazing processes, and they're constantly learning and adapting.
Right.
But what about the people behind it all? What's the SRE culture like at Google?
So Google invests heavily in training its SREs.
Okay.
They use a variety of methods, including simulations,
Sure.
on-call learning checklists,
Okay.
and even something they call disaster role-playing.
Wait, disaster role-playing, like a zombie apocalypse scenario?
Not quite,
Yeah.
but they simulate different types of failures and have engineers practice responding to them under pressure.
So they're basically wargaming different disaster scenarios to make sure they're prepared for anything.
Exactly. And these exercises are actually pretty fun, too.
Okay.
They have catchy names like Wheel of Misfortune or Walk the Plank.
I like how they inject some fun into something as serious as disaster preparedness.
It helps people learn and retain information better,
Yeah.
and it creates a more engaging and collaborative learning environment.
That's fantastic.
Yeah.
It sounds like they've created a culture of learning and preparedness that's woven into the very fabric of their engineering teams.
Absolutely.
This is fantastic.
Yeah.
This is just the beginning of our deep dive.
Yeah.
We've got much more to explore.
Oh, yeah.
So stay tuned.
One of the things that struck me as we were looking through this material is just how unique Google's production environment is.
Yeah.
It's not just about the sheer size. It's the way they've built their whole infrastructure with reliability baked in from the ground up.
It really is a different way of thinking about things.
Yeah.
Even the way they use the word server is unusual, which I found really interesting.
Absolutely. They make a clear distinction between the software running on a server and the physical machine itself.
Right.
It's not like they dedicate a specific machine to a specific task.
Okay.
Instead, they use this cluster management system called Borg to dynamically allocate resources.
So it's like thinking of their infrastructure as this giant flexible pool of resources that can be shifted around as needed.
Exactly. And this allows them to handle those thousands of machine failures we were talking about earlier.
Right.
If one machine goes down, Borg simply moves the software to another machine seamlessly.
It's like a game of musical chairs for their software.
Yeah.
But nobody ever loses their seat.
Right.
It really highlights their focus on redundancy and resilience.
Right. And that thinking extends to their data centers as well. They're all connected by this massive globe-spanning network called B4, which uses a software-defined networking approach.
So B4 is like the central nervous system connecting all of Google's data centers around the world.
That's a great analogy.
Okay.
And it's not just about connecting them.
Yeah.
It's about ensuring massive bandwidth and the ability to dynamically route traffic to wherever it's needed most.
It's like they've created this incredibly adaptable network that can handle anything thrown at it.
Exactly. They've put a lot of thought into making sure their infrastructure can handle failures and keep their services running no matter what.
It makes you wonder how they even measure availability with a system that's so distributed and redundant.
Well, that's where their focus on request success rate comes in.
Okay.
Instead of just looking at uptime, they're more concerned with the percentage of user requests that are successfully completed.
So it doesn't matter if a few servers are down here and there, as long as the system as a whole can still handle those user requests coming in.
Precisely.
Yeah.
And that's why they define availability in terms of nines. You've probably heard of 5 nines availability.
Yes.
Meaning their services are up and running 99.999% of the time.
5 nines, that's like saying their services are only down for a few minutes a year.
It is.
How do they actually ensure their services hit these reliability targets?
So they use something called service level indicators, or SLIs.
Okay.
These are specific metrics that measure how well a service is performing, but from the user's perspective.
So SLIs are all about what the user actually experiences, not just some internal metric that might not really reflect how well things are working for the people using the service.
Right. And they tie those SLIs to service level objectives, or SLOs, which are specific targets they aim for with each service.
So the SLOs are like the promises they make to their users about how reliable a service will be.
Exactly. And if they don't meet those SLOs, there can be consequences. That's where service level agreements, or SLAs, come in.
Wow, that's a lot of acronyms to keep track of.
I know, right?
But I get it now. They've got this structured way of defining and measuring reliability.
Yeah.
That's all focused on the user's experience.
They do. It helps ensure they're prioritizing the things that matter most to their users.
It's brilliant.
Yeah.
But I bet even with all this planning,
of course,
and these high standards, things still slip through the cracks.
Of course. No system is perfect, and things are always changing.
Yeah.
That's why Google puts so much emphasis on incident management and learning from those incidents.
Yeah.
Remember, hope is not a strategy.
I love that saying.
It's a good one.
It really highlights the importance of being prepared.
Yeah.
And having a plan to deal with those inevitable failures.
Absolutely. And their approach to incident management is fascinating.
Okay.
They have clearly defined roles and processes to ensure everyone is on the same page and can respond effectively.
Okay, let's dig into this incident management process a bit more.
Sure.
What kind of roles are we talking about?
So you have the incident commander, who's the leader and ultimately responsible for resolving the incident.
Okay.
Then there's the operations role, which focuses on actually fixing the problem.
Okay.
And then you have the communication role, who keeps everyone informed about what's happening.
So it's like a well-coordinated team, each member with their own area of expertise. It sounds like they're trying to avoid that too many cooks in the kitchen scenario.
Exactly. And they also have a planning role, which might seem a little counterintuitive in the middle of an incident.
I can see why that might seem odd.
Yeah.
Why would they need someone focused on planning during an incident? Shouldn't everyone be focused on putting out the fire?
That's true, but the planning role is all about thinking ahead. It's about making sure they're not just fixing the immediate problem, but also learning from it and figuring out how to prevent it from happening again.
That makes sense. So they're not just reacting.
Right.
They're proactively trying to prevent those fires from starting in the first place.
Right. They're thinking about the long-term health of the system, even in the midst of a crisis.
That's a really impressive approach.
Yeah.
It shows they're committed to continuous improvement.
They are.
So what kind of tools do they use to manage all of this? I'm imagining some super advanced dashboard with blinking lights and real-time data streams.
So they do have some pretty impressive tools, but it's not just about fancy dashboards. It's about having tools that support their processes and make it easier for engineers to collaborate effectively.
So what are some of the key tools they're using?
One of the most important is their incident management system called Outolator.
Outolator. Another one of those Google-specific names that sounds like it's straight out of a science fiction movie.
I know, right? But it's a really powerful system that helps them manage incidents in a structured and efficient way.
So it's not just about putting out the fire. It's about documenting everything so they can learn from the experience and prevent similar incidents from happening in the future.
Exactly. They use Outolator to analyze data from past incidents, identify patterns, and figure out how to improve their systems and processes.
So it's all about learning and getting better over time.
It is. That's a great way to put it.
It sounds like Outolator is their incident command center.
Yeah.
Helping them make sense of all the chaos and turn those failures into valuable learning experiences.
That's a great way to put it. And this focus on data analysis is a key part of their SRE philosophy. It helps them understand what's causing incidents, identify areas for improvement, and ultimately make their systems more reliable.
This theme of learning and adapting seems to be a constant in everything they do.
It really is. And this learning process isn't just about the technical aspects of SRE. It's also about the human side. The culture and the teamwork that make it all work.
I was just thinking about that. What is the SRE culture like at Google? It seems like it would take a special kind of engineer to thrive in that environment.
You're right. They need engineers who are not only technically skilled, but also comfortable with ambiguity, able to think on their feet, and excellent communicators.
So it's not just about being a coding whiz.
Right.
It's about being able to work effectively in a team.
Yes.
Solve problems under pressure.
Yes.
And communicate clearly throughout the process.
Exactly. And Google has a unique approach to training their SREs.
Okay.
Giving them the skills and experience they need to handle the challenges of this demanding role.
Okay, now I'm really curious about this training program.
Yeah.
What does it involve?
So one thing they encourage is for engineers to develop a deep understanding of how systems work, even if they've never seen them before.
Yeah.
They call this being a reverse engineer.
A reverse engineer.
Yeah.
It's like taking apart a clock to figure out how it works, except it's a complex software system instead of a clock.
Exactly. They want their engineers to be able to dig into the code, trace the flow of data, and really understand how everything fits together.
That sounds like a pretty intense learning process.
It is.
Yeah.
But it's essential for being able to troubleshoot problems effectively.
Okay.
And they don't just throw engineers into the deep end.
Right.
They provide a lot of support and guidance through things like on-call learning checklists and mentoring programs.
So it's like an apprenticeship.
Yeah.
Where new SREs can learn from the veterans who've seen it all.
Right. They recognize that experience is invaluable in this field.
Yeah.
So they try to create opportunities for new engineers to learn from those who have been there and done that.
That's a great approach.
Yeah.
It sounds like they're not just focused on technical skills, but also on fostering a culture of collaboration and knowledge sharing.
Absolutely. They have regular production meetings where engineers can discuss challenges, share lessons learned, and come up with ideas for improving their systems and processes.
I love that.
Yeah.
Creates a space for open communication and continuous learning.
It does.
Tell me more about those production meetings.
Sure.
What are they like?
So they're usually pretty informal, but they have a clear structure and purpose.
Great.
Each team discusses the performance of the services they're responsible for.
Yeah.
Analyzes any recent incidents. And makes recommendations for improvement.
So it's not just about reporting on what's happening.
Yeah.
It's about having a constructive discussion.
Yeah.
About how to make things better.
Right.
It's like a continuous feedback loop for their systems and processes.
Exactly. And those meetings are a great way to keep everyone on the same page and ensure that knowledge is shared across the team.
It sounds like they've created a really effective system for fostering collaboration and learning.
They have.
But what about those disaster role-playing exercises we talked about earlier?
Oh, yeah.
Those sound really interesting.
Those are legendary at Google.
Okay.
They call them Wheel of Misfortune.
Okay.
Or Walk the Plank.
Okay.
And they're basically simulations of real-world disasters.
Okay, now I'm really intrigued.
Yeah.
What happens during these exercises? Do they, like, shut down the entire Google search engine?
Not quite.
Okay.
But they might simulate a major data center outage or a critical system failure.
Okay.
The idea is to put engineers in a realistic, high-pressure situation and see how they respond.
So they create these scenarios where things go terribly wrong.
Yeah.
And then the engineers have to figure out how to fix them. All while the clock is ticking.
Exactly.
Yeah.
And it's not just about technical skills. Right. It's also about testing their communication, teamwork, and decision-making abilities under pressure.
I bet those exercises can get pretty intense.
Oh, they can.
But I can see how valuable they would be in preparing for real-world incidents.
They are. They help engineers think on their feet, develop their problem-solving skills.
Okay.
And build confidence in their ability to handle those critical situations when they arise.
Yeah.
And they're also a lot of fun.
Well, who doesn't love a good disaster simulation every now and then?
Exactly.
It's like a controlled way to experience the thrill of a real crisis without the actual consequences.
Exactly. It's a safe space to experiment, make mistakes, and learn from those mistakes.
Okay, so we've talked about the technical side of SRE at Google.
Right.
Their incredible infrastructure, their rigorous processes, their impressive tools. But what about the human side? What are some of the key takeaways about the SRE culture?
One of the most important things is their emphasis on collaboration and knowledge sharing.
Okay.
They've built a strong culture of helping each other out, learning from mistakes, and always striving to get better.
It's like they've created this environment where it's okay to fail.
Right.
As long as you learn from those failures and share those lessons with the team.
Absolutely. They recognize that failure is inevitable.
Yeah.
And they've built a culture that embraces it as an opportunity for learning and growth.
I really admire that.
Yeah.
It seems like they found a way to create a culture that's both highly technical and deeply human.
They have. And that culture is a big part of why they're so successful at maintaining reliability at scale.
This has been an incredible journey exploring the world of SRE at Google.
Yeah.
I'm feeling a little overwhelmed by all the information, but in a good way.
Me too. It's a truly impressive system they've built.
Yeah.
And it's inspiring to see how much thought and effort they put into keeping everything running smoothly for their users.
It's definitely making me think about how we can apply some of these principles to our own work.
Me too. I think there's a lot we can all learn from Google's approach.
Yeah.
Even if we don't operate at the same scale.
Well, this is just the beginning of our deep dive.
Yeah.
We've got even more to explore. We'll go back to the deep dive. We're continuing our exploration of site reliability engineering at Google. And in this final part, we'll be looking at some specialized areas that really showcase their commitment to building rock-solid systems.
Yeah, we've covered the high-level principles and processes so far.
Right.
But now it's time to get into the nuts and bolts of how Google tackles very specific challenges.
I'm ready to get down to the nitty-gritty. Let's start with data integrity.
Okay.
We touched on this earlier.
Yeah.
But I'm curious to learn more about how they protect their most valuable asset, data.
Right.
After all, without data, Google wouldn't be Google.
Absolutely. One thing that really stood out to me is their emphasis on diversity and redundancy when it comes to data storage.
Okay.
They don't just keep data in one place. They have multiple copies spread across different types of storage.
Okay.
And even different geographic locations.
So it's like that old saying, don't put all your eggs in one basket.
Exactly.
They're spreading the risk to make sure they don't lose everything in a single incident.
Exactly. They understand that any single component can fail. So they design their systems with multiple layers of protection.
Okay.
Think of it like a fortress with multiple walls and defensive positions.
It makes sense.
Yeah.
But how do they decide how many copies of data to keep and where to store them?
Right.
It seems like a tricky balance between redundancy and the cost and complexity of managing all those copies.
It definitely is a balancing act. They have to consider things like how important the data is.
Okay.
The different types of failures that could occur.
Yeah.
And the cost of storing and managing those copies.
So it's not a one-size-fits-all approach.
It's not.
They customize their data protection strategy for each service based on its specific needs.
Exactly. And they're constantly reviewing and updating their approach as technology changes and new threats emerge.
So it's like a constant game of cat and mouse, always trying to stay one step ahead of potential problems.
You could say that. Now let's dig a little deeper into those layers of protection.
Okay.
What are some of the specific things they do to safeguard their data?
I'm all ears.
Well, they use different types of storage media, from hard drives to tape drives.
Yeah.
And they store data in geographically diverse data centers to protect against things like regional outages or natural disasters.
So they're thinking about everything from a simple hardware failure to a major earthquake that could take out an entire data center.
Right. But even with all these precautions, data can still get corrupted.
Of course.
No system is completely foolproof. That's why they have another layer of protection, something called out-of-band data validation.
Out-of-band data validation. That sounds very technical.
It does.
Can you break that down for me?
So it essentially means they have systems that constantly check the integrity of their data.
Okay.
But they do it completely independently of the main storage systems.
Okay.
It's like having a separate team of auditors constantly double-checking the books to make sure everything adds up.
So they're not just trusting that the storage systems are working correctly. They're actively verifying the data itself.
Exactly. And they've built incredibly sophisticated tools to do this.
Yeah.
One of the best examples is Google Drive's automatic data validation and repair system.
Okay, now you've got my attention.
Yeah.
How does this Google Drive system work?
It regularly scans all the files stored in Drive.
Okay.
Comparing the actual contents of each file with the metadata stored in their databases.
Okay.
If it finds any inconsistencies, it automatically starts a repair process to fix the problem.
Wow, so it's like a self-healing system.
It is.
That can detect and fix corruption before anyone even notices.
Yeah.
That's impressive.
It really is.
Yeah.
And this system has actually prevented some significant data loss incidents.
Wow.
There's a story about how it saved the day when a bug caused some files to become corrupted.
Oh, wow.
The system detected the problem and fixed the files, preventing any data loss for users.
That's a great example of how those extra layers of protection can really pay off.
Right.
It's clear that Google takes data integrity very seriously.
They do. They understand that data is their lifeblood, and they're willing to invest the resources to make sure it's protected.
All right, so we've covered data integrity.
Right.
What's another area that showcases Google's commitment to reliability?
So Their approach to launching new services really stands out.
Yeah.
They have this incredibly thorough checklist called the Launch Coordination Checklist that covers everything you could possibly think of about the launch process.
A checklist. It seems a little basic for Google, don't you think?
You might think so.
Yeah.
But checklists are a surprisingly powerful tool for managing complex processes, especially in high-pressure situations like a new service launch.
Right.
There are so many moving parts, so many things that could go wrong.
Right.
A checklist helps ensure that every detail is considered and nothing gets overlooked.
I can see how a checklist would be valuable in that kind of environment.
Yeah.
So what kind of things are on this launch checklist?
It covers a wide range of areas, from technical aspects to communication and how they work with stakeholders. They think about things like capacity planning, performance testing, user experience, and even making sure the documentation is ready to go.
Wow.
It's very comprehensive.
So it's not just about making sure the service works from a technical perspective.
Right.
It's about making sure the entire launch is a success.
Yeah.
From every angle, including the user's experience.
Exactly. They want to make sure that new services are launched safely, reliably, and with minimal disruption to users. They want everything to go smoothly, and for users to have a positive experience with the new service.
It sounds like they're trying to anticipate every possible problem and have a plan in place just in case.
You got it. And they've gotten very good at adapting their checklist to different types of launches. They recognize that launching a mobile operating system like Android presented unique challenges. So they adjusted their checklist accordingly.
Launching something as complex as Android must have been a huge undertaking.
Oh, yeah.
They had millions of users to think about, not to mention a whole ecosystem of developers building apps for the platform.
It was a massive project, and they had to account for things like over-the-air updates, app compatibility, and security in ways they hadn't really had to before.
It's fascinating how they can adapt their processes to different challenges while staying focused on reliability. What are some other unique challenges they've faced when launching new services?
So one challenge they highlight is the need for flexibility. They understand that not all launches are the same. Some are major projects that require months of planning, while others are smaller changes that can be released much more quickly.
So they have to be able to adjust their approach based on the complexity of the service being launched.
Precisely. And they've come up with different strategies for handling these different types of launches. For example, they might use a canary release process for smaller changes. Where they gradually roll out the change to a small percentage of users. Before making it available to everyone.
That's a clever approach.
It is.
It allows them to test the waters and see how things work in a real-world environment. Without risking a major disruption if something goes wrong.
Exactly. It's about minimizing risk and reducing the impact of potential failures.
It's impressive how they can move so quickly.
Yeah.
While maintaining such a high bar for reliability. Okay, so we've discussed data integrity and launching new services. What's another area where Google's SRE expertise is particularly noteworthy?
Their work with distributed systems is particularly fascinating. They've come up with some truly innovative solutions for building and managing systems that span multiple data centers, even across continents.
So we're talking about systems where the data and processing are spread out across many different physical locations.
Exactly. And this creates a whole new set of challenges. You have to deal with things like network latency. Keeping the data consistent across all those locations. And making sure the system can handle failures in any one location. It gets very complex very quickly.
It sounds like a logistical nightmare. How do they even begin to approach these kinds of challenges?
One of their key tools is something called distributed consensus. It's a way for multiple computers to agree on a shared state, even if some of those computers fail. Or the network connection between them becomes unreliable.
So it's like a way for computers to reach an agreement on what the correct data should be, even if some of them are having problems or disagreeing with each other.
That's a good way to think about it. And it's absolutely essential for building reliable distributed systems.
Okay.
They use distributed consensus for all sorts of things,
Yeah.
from managing locks and electing leader nodes to ensuring data consistency across multiple copies of the data.
Okay, I'm starting to see how this all fits together.
Yeah.
So distributed consensus is kind of like the glue.
It is.
That holds these complex systems together, making sure everything is in sync even when things go wrong.
Exactly. And they've developed some incredibly sophisticated algorithms for making this happen.
Okay.
Like Paxos and its variations.
Paxos, it sounds like something out of Greek mythology.
It kind of is,
Oh, yeah.
but it's a very powerful algorithm that underlies many of Google's distributed systems.
It's amazing how they can take these abstract theoretical concepts and apply them to solve real-world problems at such a massive scale.
They really are masters of their craft.
Yeah.
And they're constantly pushing the boundaries of what's possible with these kinds of systems.
Well, this has been an incredible journey exploring the world of SRE at Google.
Yeah, it has.
We've covered so much ground, from the core principles to their approaches to data integrity, launching new services, and managing those incredibly complex distributed systems.
Right.
I'm feeling a bit overwhelmed, but also incredibly inspired by what they've accomplished.
They've done a lot.
So as we wrap up this deep dive, what do you think are the most important lessons we can learn from Google's experience with SRE?
One of the biggest takeaways is that reliability isn't just about technology.
Okay.
It's also about culture.
Right.
Google has built a culture of continuous improvement, collaboration, and a deep respect for the complexity of the systems they're building.
That's a great point. They haven't just solved the technical challenges.
Right.
They've also figured out how to create an environment where people are empowered to innovate while keeping reliability top of mind.
Absolutely. And they've shown that it's possible to move fast and innovate while still maintaining incredibly high levels of reliability. It's a delicate balance, but they've managed to strike it.
It's truly inspiring. It shows what's possible.
It does.
When you make reliability a core part of your engineering culture from the ground up.
And never forget, hope is not a strategy.
Yeah.
But learning from Google's experience with SRE can definitely help us all build more reliable and resilient systems.
Yeah.
No matter what scale we're operating at.
That's a great reminder.
Yeah.
Thanks for joining us on this deep dive into the world of SRE at Google.
My pleasure.
We hope you found it valuable and are leaving with some new ideas and insights. Until next time, keep learning and keep exploring.